2 weeks ago on the Global Health Pursuit podcast, we spoke with Sign's founder and president, Dr. Louis Zirkle. Last week, we spoke with Gene Dillner, Sign's CEO. And this week, we get to speak with Sign's very own engineering manager, Terry Smith. Today, we're diving deep into the engineering of it all. Now, I'm not going to bore you with all of the technical details of the engineering world, but I really did want to know how Terry and the Sign team work together to create orthopedic implants and instruments that serve patients in populations that don't necessarily have reliable electricity, and places where the infrastructure may not be the greatest. Now, according to the WHO, about 1.3 million people die each year from road traffic crashes, and more than half of these deaths occur among vulnerable road users, pedestrians, cyclists, and motorcyclists. Now, on top of this, between 20 to 50 million more people suffer non-fatal injuries, and many of these people incur injuries that are disabling, to say the least. As the engineering manager, Terry speaks to us about how Sign's design process to create trauma implants and instruments is so different than the norm. He speaks with us about how they work with surgeons from all around the world to create better products and implement relevant education so that each Sign surgeon is able to optimally treat their patients. So how do they begin to create devices to serve these patients? Keep listening to find out. Before we get into the episode, here's a little bit about Terry. Terry joined Sign in January of 2017 as the engineering manager, responsible for developing and maintaining Sign products. He brings a broad background in product design, product development, program and project management in the aerospace, renewable energy, and instrumentation technology, with experience in small and large organizations, allowing him to navigate the challenges and rewards of startup companies and corporate organization. Prior to joining Sign, Terry held leadership positions at the Boeing Company, Infinia Corporation, and Bruker. Throughout his career, he has worked with domestic and international teams and customers to turn ideas into designs and products. Terry's an inventor on 4 different patents and earned his Bachelor of Science in Mechanical Engineering from the University of Wyoming. My name is Hetal Baman, and this is the Global Health Pursuit. Hi, Terry. How are you?
I'm good, Hetal. How are you?
I'm so great. I just want to mention that I've been looking forward to this interview so much, not just because I have a background in med device and orthopedics, but because when I first heard about Sign, I want to say like 3 or 4 years ago, I learned about the unique angle that you guys take, that your team has taken to not only design and manufacture implants for low resource areas all around the world, but honestly, like, the fact that you guys really get the surgeons involved from all around the world, it's truly, I think it's really, really inspiring. So with that being said, I want to welcome you onto the podcast.
Thank you. Yeah, no, I'm very excited. It's always, like I said, it's always fun to share about Sign, their mission, and the work we're doing.
Firstly, I want to learn about a little bit about you and get a little bit of a story behind how you got to Sign. Yeah, tell me a little bit about yourself.
Sure. Maybe I'll give you the kind of the big picture, and then I'll zero in on Sign a little bit and the relationship I've had with Sign over the years. I have a mechanical engineering degree from University of Wyoming. My career is really, spanned decades now, which is kind of scary to say that out loud. But it's kind of come in 3 phases where, and it's all been really related around product development or research, right? So I've been really fortunate, super blessed career. Started in aerospace, structural design on essentially military airplanes.
Okay, that's very different from what you're really doing now.
Right. So I had this, as I talk a little bit, you'll see that I had this huge diversity, large companies, small companies, startups, and now a nonprofit. But So did structural design work at Boeing for a number of years. I have, out of that, there was 3 or 4 patents, some of that work. It's kind of fun to walk into an Air Force museum and see an airplane that you actually have parts that you design.
Oh, so cool.
So it's really cool, right? I mean, it's just like every one of my projects that I've worked on over the years is like a dream job for some people. So I feel really, really blessed and fortunate to have the career that I have. So after spending about 16 years in that space, I decided to move to a smaller company. And that was, again, aerospace related in that we were working on deep space electrical power generators for deep space probes. And that lasted a couple of years. There were some contracts there. And the CEO at the time decided that technology could also be used in renewable energy space.
Okay.
And so we were headed down a path for a few years on developing a renewable energy product. And we didn't quite hit that curve right. Our timing was a little off. Our cost structure wasn't quite right, but the technology ended up still exists. And there's a couple companies that are using it. One for a cryocooler application. And then another is like a remote power and compressors for compressed natural gas. So those are going up. Probably the coolest thing out of that is when I first started at that company, there was like 35 of us, right? So I go from this company of 200,000 people where there's, where I can just go to the...
what your job is and you go in.
Right. Well, and then I have this list of experts, right? So if I have any question on any topic, I can go to the internal phone book and find some technical fellow that person that has been doing this for years, right? And so then I go to this 35-person startup where you had to do everything, right? Literally everything. So anyway, but that was very fun. There's kind of the unique story out of that particular group was we delivered 4 of these electrical generators to NASA in Cleveland, Ohio, at the Glenn Research Center, and that was back in about 2004 timeframe. 3 of those engines are still running, and they haven't had any maintenance done on the engines. The test stands and all of that have broken and fixed. So it's been probably a year and a half ago since I've talked to one of them, but they're still running, and that was the intent, right? They needed to have 20 or 30 year lifespan, and so they're pretty close on that. Anyway, that was kind of fun. Then I switched from that into, I kind of went into this technology space, and that was part of it. And then I had another opportunity to work for a company, and we did handheld X-ray fluorescence instrumentation.
Okay, moving into the health space. Okay,
no, it's actually not.
What?
It's more of a quality. It's more of a quality inspection tool. So it looks like this little Star Trek. Literally, it's like an old Star Trek phaser looking device. Their first one really kind of looked like that, and so it's a little X-ray and a sensor in this handheld device. And if you want to know what a metal alloy is, you can place this thing against it. You pull the trigger, it generates this X-ray. If you had chemistry and you remember your valence electrons, the X-ray knocks. Yeah, really, I don't remember that. I had to relearn it. Seriously, I had to relearn all of that. And so anyway, but it'll tell you what that alloy is, right? Or if you want to know the actual chemistry, it'll give you the chemical makeup of the alloy. And those are instruments that are used, quality control. People will use them. So if you order, so we actually have several here in the building. So when we order raw material, we want to know that what was shipped to us is what we ordered.
Right.
You have material certs, and it comes with all of that, and they're serialized, right? Particularly for implant materials. But we have had an instance where we had ordered an alloy called Nitronic 60, and they shipped us 17 for us for an instrument, which would have been a very big deal if we would have made.
Oh wow!
If we would have made parts out of it and shipped them, right? That's a huge deal to not.
Yeah.
And so that device is used to just kind of part of that's quality inspection. And so that was kind of a fun job to have for a while. And I had in all of these, I've been really in engineering management, right? So I had a team of software engineers and electrical engineers and mechanical engineers developing products around that. And then, I'm going to roll back just a little bit. So the company that I'd worked at where we were doing the deep space power generation and the renewable energy, at that time, I had one of the engineers had left us. That was a cyclic company, so we hired a lot of people, laid off a lot of people, hired a lot of people. Right? We were in that mode, and one of my engineers that I let go, he says I fired him. It really didn't happen that way. It really didn't happen that way.
You're like, it's just semantics, whatever.
No, right. Well, he had an option to take a package to leave, or try to stick it out with us and hope we raised money. And then not have anything, the potential was he was going to continue to have a job, or we weren't going to have money, and we're all looking for jobs, right? And so he chose a package so that he had some, essentially was.
And then he said that you fired him.
Then he said I fired him. He works for me again now. So it's like,
oh, wow.
That's a whole story. So he came to work at Sign. And so we met Sign and Dr. Zirkle, our founder, and Gene, the CEO, kind of through that relationship. And also I was working with Gene Dillner, the CEO, on an economic development committee where we would do manufacturing expos locally. And Sign always had a booth. And so we kind of started supporting them. Like they would come over to the engineering team that I was running and say, hey, like lunch and learns. And they'd explain to us what they were doing. And they had a couple of engineers at the time working for Sign, and we would try to help them out with ideas, right? Or do some analysis, whatever we could do to add, give them a hand on their project. So we did that for quite a while. And then at one point I got laid off in between jobs, and I'm talking to Jean, the CEO, and she's like, hey, we need you to do an internal manufacturing audit. And I'm like, Jean, I know nothing about what you're doing, right?
About med devices?
About med devices, how to do an audit. And so I happened to have an ex-colleague that she had done that for a while. And so she's like, here, Terry, I'm going to give you the crash course. And so I came to Sign for about 6 weeks and got paid like minimum wage, right? I mean, it was nothing.
And when was this?
This was back in about 2011, 2012.
Okay.
So about,
and how big was Sign back then?
There were probably about 25 people.
Okay, yeah.
Or 20, yeah. They were just trying to get their ISO 13485. So,
okay.
They'd had a couple of countries that said, hey, if you're going to ship to us, you got to be ISO certified.
And what is ISO for anybody who doesn't know about that?
It's an international standard that's used a lot for product. And it doesn't matter whether it's a medical device or if you have consumer products. It's generally a European standard. A lot of U.S. companies follow them. And so it's really a quality standard. And so it's like if you're going to develop medical devices, 13485 is required by a lot of countries, health ministries. It just tells you how to set up your quality management system. Mm-hmm. And it's really how you manage the organization, how you procure products, how you qualify suppliers. It gives you requirements around it. It doesn't tell you exactly how to do it. Well, let me just step back. ISO the ISO 101 is you tell me what you're going to do.
Right.
So you write down your processes of how you're going to do your work. Then you have to go do it. And then you have to have the paperwork that shows that you did what you said you were going to do. And that's ISO in a nutshell, right? That's really what it is. Tell me what you're going to do, go do it, and then show me that you did that in an audit. And when it comes to developing and releasing a medical product, particularly for us in the orthopedic world, there's a section called design control. And it really parallels closely what the FDA requires. And those two are starting to merge now. FDA is starting to really kind of take on that ISO 13485. And they say they're going to harmonize it. They've been saying that for years. But in the end, as for Sign, we are registered with the FDA as a medical device manufacturer. With the 13485, we have to do design control, what's called design control. And again, it's a way of a formal process to get requirements for your product. Then it's a way of you map out how you can trace how those requirements go through your design process, and then how you're going to test to make sure that so it's called design verification. The design that you did is what you said you were going to build. And then you have to do the validation side, and hopefully we'll talk about that in a little bit. But which proves that what you designed is what the user wanted, right? And so it's really that's the basics of it. And there's a lot of paperwork involved sometimes.
So much paperwork. I know. So verification is more like in-house testing, mechanical testing, all of that stuff. And then validation is is it going to work in the user's hands? Right. So that's essentially in a nutshell what verification and validation. I remember back when I was in school, there was a lot of confusion around what is that?
Even in industry, there still is, right?
Oh, interesting.
Right. So because they don't teach you, this isn't something you learn in college.
No.
Right. Unless you have a really special class, but for the most part, you don't.
Hey there, I hope you're enjoying this episode. And if you are, would you do me a tiny favor? Show me some love by doing one or more of these 3 things. A, Click the support this podcast link in the description to donate a few dollars toward the production of this podcast. My dream is to do this full time, and your support would mean the world. B, you can write me a review on Apple Podcasts and or rate me on Spotify to give me a boost in the algorithm. Or C, share this episode with someone who would love it just as much as you do. I truly and deeply appreciate you. Let's get back to the episode. Right. So what Sign does is design and manufacture implants and instruments for orthopedic trauma injuries within low resource areas around the world. I wanted to talk to you a little bit about kind of the medical device orthopedics world in general.
Sure.
And how what you're seeing year after year is just like a technology upgrade. You know, you're getting better and better and better. And then it's like, you know, the device needs all of this electricity and then all of these wires and all of these different things that you might not find in a rural clinic. So at Sign, what have you seen that is very, very different than, you know, other medical device companies? And what is the process like for you guys?
Sure. So I think in the U.S. markets, because the medical devices are so competitive, they have to have a unique selling point, right? So there's this, the USP side of it. And so that unique selling point, you know, so they're always coming up with unique ways of doing things. And it's that like, well, ours is a little bit better than yours because of this, right?
This one little aspect of it.
Aspect it may be, right? And so a good example is we treat long bone fractures, right? So the tibia, so I start down at the shin bone. So the tibia, the femur, and then the humerus, which is in your arm. And so that's what our primary goal is because overseas in low resource settings, when those are fractured and they don't heal properly, then that is literally poverty is a breakaway for a lot of these people, right? And so if they can't get treatment and it doesn't heal correctly, they don't work. And then, you know, it could be... They
can't go to school, they can't work, there's a mental health problem, so all of these things.
Yeah. And it's in some countries and in some settings it's literally a death curse to them, right? Because they can't make a living and they won't eat. And so then they're reliant on the charity of others. So we have a universal nail, right? So here's a great example. We have a couple different types of intramedullary nails. And so for the audience that doesn't understand what that is, it's essentially a stainless steel rod, and the surgeon is going to place that rod down the center of the bone canal because his goal is to stabilize that fracture during healing. And then he attaches, he interlocks that rod to the bone by putting in bone screws. And the ends of this stainless steel rod, there's holes. And so he has to put bone screws through the bone into that hole in the rod. But he does that in a low resource setting. Our system is set up to not require an x-ray machine and surgery, right? And so that's kind of the unique part of it. And there's a lot around why we have to do it that way. And in the US or in Europe, what a surgeon will do is he'll have a real-time x-ray machine and surgery. And so when he places that nail down the center of the bone canal, he sees where the holes are on the end of that. He'll know where to make an incision and where to drill a hole so that the bone screw can go into that.
Yeah, they're able to take a picture every 5 seconds to be like, okay, this is exactly the right place.
I'm in the right place, right? And so our system is you attach a nail to a targeting system, and it's placed down the center of the canal. And then on the outside of the patient, the surgeon will know using I'll call it if you're a woodworker or have done anything, it's really like a drill jig, right? It's a little jig that tells them where to make an incision, where to drill a hole. And then they can blindly place that screw into the end of the nail and interlock the nail to the bone. And so that's what our product does. And
they're doing this without X-ray technology or any of that.
Yeah, they're doing that. They'll have they have to have an X-ray to understand what the fracture is, and so And so they'll do a pre-op X-ray, but a lot of times that X-ray machine is in a different part of the hospital or a different part of the hospital campus, like literally across the campus. Or we had one surgeon, he was working at a hospital where he didn't have an X-ray machine, so they had to get their X-ray at another clinic. The other clinic didn't have orthopedics or surgery capability. So the patient would bring their X-ray with them to his hospital.
Oh, wow.
Right? So it's super crazy. So back to like, what's the differences between us and it? So we have one nail that, and it can be used in the tibia, the femur, or the humerus, and it can be used on the right-hand side of the body or the left-hand side of the body. So it's
okay.
And it can be used, say, in the femur. It'll either come down from the top of the hip, or it can be used, and that's called antegrade, or it can come up from the knee, bottoms up, into the knee, and that's called a retrograde approach. And we can use the same nail to do what's called a retrocalcaneal fusion, which is the way to fuse the ankle. So if you have a really, a low tibia fracture or the retrocalcaneal, fracture that's pretty bad, then you can fuse the ankle together, and sometimes that's required. So that single nail can do all of those, right? Where, like I said, here in the U.S. or in Europe, they're going to have a unique nail for each of those applications,
right?
Or maybe 2 or 3 unique nails, depending on the type of fracture. Our goal is to be very universal in our approach, but also do the resource appropriate design, right? And so it's really understanding what's going on in those hospitals, and the breadth of the hospitals that our surgeons work in is huge, right? So on one side, there may be university teaching hospitals in the larger cities in Africa and Asia, and they're reasonably modern, right? They're reasonably modern. They may or may not have access to the working C-arm in the hospital.
Mm-hmm. C-arm is the X-ray.
Yeah, thanks. Yes, C-arm is that real-time X-ray machine that's used in surgery, and for a variety of reasons, right? Maybe they don't have the maintenance crew there, right? They can maintain it, or they save it for surgeries that absolutely require the use of the C-arm, and they know that with our equipment, they don't have to have it in an operating theater that has a C-arm, right? So they may, depending on their surgical load on their hospital, they may choose to not use that operating theater. So that's one extreme. And on the other extreme is, like I said, a hospital that may not have an X-ray machine in the facility, and the patient has to bring an X-ray with them. And so it's that whole spectrum there that we have to do. But overseas, they don't have the same power quality. And so that's really hard on this electronic equipment. And so they just don't last as long in some of these countries. And like I said, they don't always have the trained maintenance technicians there to do the maintenance, the long-term maintenance on the equipment. So that's
right.
Yep. So that's the challenges that our surgeons and hospitals face. And so our goal then is, of course, to try to get out of this. We're trying to address with a universal design this huge spectrum of use cases, right? And so that's the fun and the challenge of some of the work we get to do, right? And I would say in the early days, Dr. Zirkle, he had, in your interviews, right, you'll just learn that he is like the most compassionate patient advocate you'll ever meet. And so he had spent a recent amount of time collecting used medical equipment and teaching surgeons overseas. And he did that for a number of years. And on a visit, there was a patient that they kept walking by, him and the surgeon that he'd been working with for several years.
Right.
And he didn't, that particular patient was in traction. He'd been in traction. And so finally, the doctor said, "Why aren't we treating this patient?" And he's like, "Well, he's in traction." His family.
So when you say traction, what does that mean?
So they'll take and attach a weight to a leg there's a couple of ways to do that. Sometimes they'll actually put pins in and attach a weight to it. And they take the fracture and they're trying to stretch it out and align the bones. Sometimes when a patient has a fracture, the muscles will contract and the bone ends will overlap and not be aligned. And so they put them into traction. That is a method to try to heal bones, but it usually doesn't work on the femurs very well to get them to align. That whole story with this particular patient made Dr. Zirkle realize that the work that he had been doing of donating used U.S. medical equipment wasn't resource appropriate design because they couldn't use it. They didn't have, it goes back to they didn't have the right C-arms, they didn't have the right equipment. And so he had spent a number of years doing this effort and realized that it was literally for naught, right?
Yeah.
And so he'd helped some people, so then he realized that he had to start sign and had to do a design of a implant system from scratch that was resource appropriate. So
what he was doing back then was just you can say that it was almost not sustainable, there would be some cases where it would work out, but then you use this one donated thing and then it's done.
Right. And then you hope that you get more of the same, right? Implants that will work with the rest of the surgical instruments, right? So that led to the formation of Sign. And so he, in the early days of Sign, he was a voice of the customer, right? He was the voice that he would travel like once a quarter for a week or 2 weeks. He'd come back. He had a whole list of ideas and things and challenges that they faced. And then at that time, the engineering team would just iterate on those designs until they developed our IM nail system that we have today.
So, okay, so that's a good point. I was going to ask you, like, what was your starting point? Did you have like a nail that you had from like a different medical device company and was like, okay, well, we're going to use this as our starting point. And then we're going to start like designing down to become universal.
Yeah, I'll try to get through that in a concise manner, right?
Yeah.
Right. So there's one thing about Sign that I find extremely fascinating. It is extremely providential. There are things that happen at Sign for if you look at it externally and you're like, how did like these people come together that were not associated with each other and things work out? So one of those fortuitous and providential moments was a gentleman, Dr. Zirkle befriended a gentleman by the name of Randy Huebner. So anybody in the orthopedic world that knows Acumed, Randy was the founder of Acumed. Mechanical engineer, super great guy. He's on our board. He's like one of our guest engineers, to be honest. He does a lot of work with us. It's super fun to work.
The honorary engineer.
He's the honorary engineer. Yeah, he's really an engineer at heart, and so it's fun to anyway. So Dr. Zirkle had contacted Randy, and they became friends out of this. And so Randy actually did the initial. They had at that time Acumed had a humeral nail to treat the humerus, and so he did a basic initial design for Sign, and it included a little bit of the instrumentation, and then from there that kind of led to the creation of the rest of the Sign system and the Sign IM nail system, I should say. And then as things progressed, there's so much I could cover here. So part of the thing that you mentioned this like early on in our conversation about our access to Sign surgeons and our ability to communicate with them. And
right.
So a lot of that is facilitated because we have a surgical database. And so what we require of hospitals that are participating with this is that they fill out case information. So this surgical database is a long bone trauma database. Right now, there's over 200,000 cases in there. And so we ask that the surgeons fill out information about that surgery. We need pre-op and post-op x-rays. But the important thing is the follow-up. What we really want is the follow-up, because then that is like the report card for the surgeon, and it's a report card for Sign, right? Because you see in there, we get to see like, was the training effective? How good was the surgery? And then what were the results of that surgery? And you get a really good indication of our devices doing what they need to be doing. That's evolved over the years. And so, but a lot of that surgical database also provided an avenue for us to provide training to the surgeons, because Dr. Zirkle reviews every case.
And I mean, you even said that before, like he literally reviews every single case.
And he will comment on cases, and sometimes the surgeons are emailing him asking questions. And so it's really, that mentoring, it was like a mentoring tool, right, that's evolved over time. And we have some board members that are also doing case reviews, and we have some of our, because we're going to be in 2024, it'll be 25 years that Sign has been doing this.
Yay.
Right.
Wow.
Super amazing, right? It has been that sustainable. So we have mentors now. Some of our surgeons, like literally the mentors have become the teachers, or the students have become the mentors.
Right.
So they're reviewing cases too, and they're doing comments. So it's kind of fun to watch how this is kind of becoming a little bit more distributed and not just, focused on Dr. Zirkle and his ability.
You're just going to do this forever. It's okay.
Well, it makes it sustainable, right? That's really, That's really what it is. And that's the goal, right? That's the whole goal, to do. And so, yeah. So anyway, that's an aspect of the training, but it also gives us a lot of feedback on the engineering team. It takes some time to go study cases and get through it, because the database is not structured for us to do research on. It really was structured around the report card, which is all right. It means that there's some great tools now that we can use, and we can look at cases. So we review a lot of x-rays, and then there's a whole part of the FDA and ISO that's called post-market surveillance, where medical device companies need to monitor their devices and while they're in the field use. And so this is a great tool for us to do that. And I'm not aware of other medical device companies that actually have this level of detail at this magnitude of information. So,
even for post-op and that is really huge. I think, when you think about, like, if you're an engineer and you're listening to this, the engineering process within the orthopedics or med device in general, you have the whole design control process where you go from inputs to outputs and you got to do like your verification and your validation. So how is it different from like a regular design control process? Because first of all, you can't just like call your doctor just like randomly and be like, hey, like I need you to come in and like, let's talk about like voice of customer and then and then iterate and your validation testing where you want to get this equipment right, in their hands and like check off the boxes.
Right.
How is that different from like a regular design control process?
Sure. In the early days, they didn't know a lot about FDA. They didn't know a lot about stuff. And so they just, Dr. Zirkle, they would design a couple things. Yeah. And then Dr. Zirkle would take it on a trip and he'd use it. And so, so it was like prescribed, essentially it was prescribed devices, right? So what they were doing at that time. So Dr. Zirkle would talk to surgeons ahead of time on the trips. What kind of cases do you have? And then, he would take nails, implants, maybe a few instruments that, because they talk through what might be needed or based on the previous trip, be like, if I had this instrument, it was slightly different. And so that's how the system evolved in the early days. Now that I'll say the IM nail system is fairly mature and it's got a lot of feedback on it. The way it works is we'll get, whether it's through the database, through email conversations, or the one thing I haven't talked about is we do an in-person conference once a year. Okay. Except on those really bad COVID years. We do an in-person conference and it used to be that we would have like 120 or 130 surgeons that would show up at our headquarters in Richland, Washington. So it's out in Eastern Washington. And then it'd be 4 days of surgeons giving lectures on like they would do presentations. They'd have to, apply to do, here's the abstract, send it in. Dr. Zirkle and the sign team would approve them. Then they'd group them together based on topics. Yeah. And then, so it was a lot of peer-to-peer learning between the surgeons. But in that, what the engineering team would get was you start hearing the voice of the customer, like, see what the needs are, right? So then that would lead to conversations during lunch and breaks and in the evenings, like, hey, sketches, like, what do you need? You'd also, we do sawbones training on the system, on the different approaches. And so engineers we get to do all of that training with those surgeons. And, sometimes it's super fun when you have a young resident that's come over from another country and they really don't know the system. You get to train them. And then you'll have a mentor there. You have somebody that's done maybe 1,000 surgeries.
Oh, right? Wow.
And you look at their name card and you're like, oh, yeah. Right. You need to be teaching, right? And right.
Not me.
Right. It's pretty intimidating. But then they're like, they're really good because they're very respectful and they're like, they just interject like, oh yeah, but if you try this, and so they would, so it's pretty fun to listen to them. And then out of that, then of course, if as an engineer, you're just like, it's a dream, right? That you have all of this huge customer base and you hear the voice of many customers.
Do you see a difference between like from one country to another country or like, between cultures as well? Like, is there maybe a difference in the way that, I don't know.
There are some. Yeah. Sometimes the bulk of our surgeons are native to their countries, right?
Okay.
But we also have a lot of U.S. surgeons and/or like Italian surgeons. There's a couple of Italian surgeons in Kenya, but in particular the U.S. surgeons. Some of them maybe are going over because they're doing it's a mission trip for them. Right. But they're over there 6 months out of the year, or 3 months out of the year, or they're over there 2 or 3 years, and then they have to come back and do U.S. boards and work in the U.S. for a couple of years, and then they go back. Right. And so some of them have dedicated their life to helping the injured poor. Very much like Dr. Zirkle, but they're living overseas and doing that. And so Sometimes the U.S. surgeons, particularly ones that travel over there, they can be a little bit like, no, I like my way of doing it. But and so they have adapted our surgical technique to a method that they have. And so and so sometimes it's like, well, we designed it to be used this way, right? And so you end up in discussions, and that's all right. That's all right, right? And so because sometimes we find better ways or different ways of doing things. So that's probably one difference where, like, particularly in Asia, they are like super respectful, and they're very good at following through the technique. They're very good at you have to listen very carefully for them to tell you that they don't like something. Because they don't always, they're not black and white in telling you that.
Right.
And so we give them permission a lot of times. Like, I need you to tell me what is bad. What is,
I know, right? So it's
from
okay.
Your perspective, like, what is it that isn't working for you? Like, what is it? Because I can't fix it unless you don't tell us. Right. And so sometimes you have to give them permission to do that. And I would say the African surgeons come in, some of them are very like, once you have that conversation about, you have my permission to tell us, right? Because they also don't want to like tell you that something's, I don't want to say wrong, but it's like,
this sucks.
We could do it differently, right? You can make it better, and you can do it differently because they understand what we're doing, right, and how we're helping people. And so we have some great examples of stuff where we've gotten feedback, and it's driven changes in our design. We have a collinear clamp that's used to like clamp the bones together to help in what's called the reduction, so aligning the bones up. And we went through a whole the design verification and validation steps, and then the surgeons started using it, and a couple of them were like, hey, the handle's too small, I need to put more pressure on it. I'm using it, it was designed for long bones, but they're like, I'm using it in pelvic surgery and I need a longer grip and I need to do this. And so can you change the shape of that handle so it doesn't hurt my hand so much? And so it's just something really simple that's that ergonomic side of it where, they actually expand the use of our devices. And so then we go back and we make an iteration on it. So, that's part of what we get to do with them. And so when we do our bench testing, a lot of times it's with sawbones. They're foam replicas of bones. Dr. Zirkle will do the surgeries with us. We work out a technique with that. With this in-person conference, then we try to do all our new devices there. There's usually, we have breakout sessions where we're showing them all our new devices. But again, it's really like we're capturing feedback. We're like watching them how they use it, because you try to make your devices very intuitive on how to use. And so you'll show them that. And so you'll see like, oh, they don't understand, right? Whatever it is, our Western way of thinking on how isn't maybe like the way that they were, they don't have that experience or that. So we have to think about it differently. And so then you watch them and it's like, well, okay, why did you pick it up that way? And how did you handle it this way? Why was it that you did that? And so some of it is it's just they were taught a certain way. And so then it makes us have to think about that, how we do our devices slightly differently. And so the other thing that we actually have had this in the last 5 conferences is we've had bioskills labs. So it started out where we had a company, and I'll promote them, Surgical Training Institute, and they're out of Vancouver, Washington. They show up with a semi-tractor trailer, and it has 8 surgical stations in it, right? It has slide outs. It slides out to be a triple wide. They have 8 surgical stations, and then they were donated specimens. And we did 3 days of essentially cadaver training with these surgeons from overseas. And so that's another way. So now we're going to do the validation side, right? Yeah, right. So it's super fun. And since then, we've actually been able to remodel our building, and we actually have our own bioskills lab now. And so we commissioned it last fall. We had a conference, and we've kind of decided to change our annual conference to be more like 30 or 40 surgeons. So a little smaller, a little more intimate. But again, we had 8 bioskills sessions in there, a couple spine sessions with some spine surgeons and doing spinal trauma initial training, and then all the long bone training. And so we are in there. We have a skin graft system we're working on right now. And so we were in there with the surgeons, like practicing and like having them test it, giving us feedback. Oh, if you can change this. And so part of that started in a breakout session where it was a benchtop testing.
Yeah.
And then we had a chance to move it into the lab and had them use it with the specimens and give us feedback. And so we have this really unique opportunity of how we get to do our verification and validation. And so, or maybe we have a board member that's visiting, or sometimes local orthopedic surgeon, and we'll ask them if they can do some work with us and do the the validation side of it. Yeah. So anyway, super fun that we have the access to these surgeons.
I think that is so cool. I just want to ask you, like, how cool is it for you to see Sign evolve over the years?
It's really fun because in the early days, I didn't have a ton of exposure to, so I didn't ever finish my story, right? So I did that short part-time stint with Sign back about 11 or 12 years ago.
Oh, right.
And then after that, the company that I was working for that did the little Star Trek handheld X-ray fluorescence, we would sponsor tables at their fundraisers.
Okay.
So I knew two of the engineers here had worked for me in the past, so it was always fun to show up and kind of talk to them at the fundraisers. And then Gene, the CEO, and I, like I said, we are on this committee together, so I'd see her 2 or 3 times a year outside of a Sign. And then one day, my job that I had was a super good job, but I was ready to move on. Culturally, there was a lot. I was ready to move on from a corporate culture, quarterly profit standpoint. Mm-hmm. Like, you get it. If you're ever into that, engineering's a cost center, and it's just like, they were going to save their way to prosperity. They didn't know how to sort out and do a product and sell products well. And so anyway, I was kind of looking, and the CEO, she called me up one day. She's like, "Hey, I think we're making changes in the engineering department. Are you interested? Do you want to come talk to us?" And I said, "Sure." She goes, "Okay, well, why don't I meet you for dinner?" And she had an auditor that was in the building that day and she goes, "I want you to meet Sarah, our internal auditor." And all right, I can do that. So I go to dinner. Well, it wasn't just Gene and the auditor; it was the rest of the management team.
Oh my God! It was an interview. They ambushed you.
Right. Well, and I knew, I kind of knew most of them. So anyway, that conversation led to a job offer, and so I walked away from the corporate world to come join Sign, and that was 6 years ago. And don't regret it one bit at all. Right. I'll have a different retirement than probably what I would have had before, but whatever. I have so much more satisfaction in what I'm doing and the impact that we're making. So anyway, it's anyway, that's part of my.
I mean, I can see it in your face.
Yeah,
like,
right.
I mean, it's 6 years. It's not like you're a new engineer and you're like, "Oh, am I so excited?" It's just like it seems like, every day it's just like a new adventure.
It is totally a new adventure. Part of that's Dr. Zirkle. Part of that's because he is an entrepreneur at heart, mm-hmm. And he just will be like, "Yeah, okay, I know you guys are working on this, finish because I need to go to the next thing and right." And so he's always challenging and pushing us, and that's contrary to an engineer, right? We like to be very sequential and work through a problem,
right?
So that's it keeps us on our toes for sure.
It's like almost like a startup environment.
It is in a lot of ways.
Yeah,
it is. And
wow.
Yeah. So what else?
We could
go on for a couple hours.
I know, but I really want to close this interview by, asking you what's in the works for Sign. What are you most excited about for the future?
There's a couple things there. I think, one of them is we had about 4 years ago, we met a couple spine surgeons at the Canadian Orthopedic Association conference. And so Dr. Zirkle and Gene and I had gone up there and we did some sawbones training to session during their conference. And so there was a young surgeon there. She was just starting her spinal residency, Supriya Singh. And so she kind of reached out to us like, "Hey, what would you ever, we've been thinking about spine trauma and we would like to learn about your model and what you do at Sign. And could we do something with spine?" That has evolved into there's a whole spine team. Supriya's on there, another Dr. Param Razunajad, and I always am terrible at pronouncing his name. another Canadian spine surgeon, and then we have a Dr. Mike Kasia that's out of Indiana. He's on our board. They're like the core of this team, and then we have another this surgeon, Soraya Karomi. She's at HSS back in New York, another spine surgeon. She's actually been acquainted with Dr. Zirkle for years. When she started medical school, she reached out. She's good friends with one of our spine surgeons in Myanmar, Dr. Ong. She's traveled over there a couple times. Anyway, so that kind of those four are starting to develop with some neurosurgeons a plan to do spine trauma.
Oh wow!
And to the goal is to set up a couple training hospitals in Africa and in Asia. So right now there's Kenya, Tanzania, and Nepal are the places that they're initially targeting. And so it's really to go in and treat thoracic lumbar injuries for the most part, and then have rehabilitation on the backside, right? They have to have all of that, but it's really to set up a residency program in those countries so that we have a Nepali surgeon and a Kenyan surgeon that are doing their spinal residency in Canada at Western. And so they're going through and I should say their fellowship. It's really their spinal fellowship there. And so Param has been able to get that coordinated with the university there. So then they will go back to their countries, and then they will start a spinal there. Fellowship program at those hospitals in those countries. And then it'll be like 1 or 2 fellows a year. And then, the key there is going to be like, can they get implants at quality implants at a reasonable cost that's sustainable, right? And so there's a couple parallel efforts there. Can we find the right quality of implants that are cleared with the FDA? That's kind of like one of the requirements we want, because that they've gone through the appropriate testing, and then is the right cost structure. So there's also an effort of doing some conceptual designs of pedicle screws right around that, and so that's for me that's super exciting. Partly because my grandmother was paralyzed, and I saw the struggle that she went through back in the 60s and 70s.
Right.
Which I think is some of those countries, their medical capability is similar to what we had back in those days in some ways, or maybe less. And so having that ability to get treated for that spinal trauma is kind of a big deal. So that's one aspect there. It's getting treated separate from the long bone efforts. So they have to raise their own funds, right? We're a nonprofit. So it's like, we don't want to take away from the long bone, because then that becomes an opportunity cost for who we can serve, right? And so they're working through all of that, and it's super fun to watch them. They're very, very passionate, obviously extremely intelligent. So for me, it's fun to work with all of these people that have extremely articulate and that make me think differently. And, so they raise you up, right? That's really the cool part. And with it. And even overseas, the surgeons overseas, like these guys are incredibly good surgeons.
When you think about it, right? Like these surgeons are doing these surgeries in these types of conditions where like they don't have the X-ray, the technology, and all of the fluoro.
Crutch.
They don't.
Right.
And that's what we see sometimes in the U.S. hospitals, where it's like, oh, I'm not really sure. I'm just going to take a picture here, or I'm going to take a picture here, and you're not able to do that. So it's
right. So they become very, very good surgeons. They're very tactile oriented, and some of you see, looking at X-rays, and you see the huge defect maybe from that injury, and then how it turns out, and you're like, this is amazing, right? It's totally amazing. So that's spine. I'm going to go back. Spine's one of the aspects I'm pretty excited about to see where it ends up. We have a new system. We're going to launch a skin graft system that will be this summer. We'll get that out into the field. So low cost. When you see a lot of the road traffic accidents, there's a lot of pretty severe soft tissue damage. And so skin flaps and the ability to take a skin graft and cover up some of those damaged areas is pretty important. It'll also probably get used in a lot of burn victims. You see that in a lot of the countries where they're using wood and cooking fuel for cooking. There's a lot of pediatric burn patients because a child reaches up and grabs a pot and boiling water or something. So you see a lot of that. And so that's another one that we know will be super impactful. And then we're also dabbling in infection control and infection prevention, which is, for engineers is like totally weird, right? But, a lot of our cases present late to the hospital, right? So in most of these countries, they don't have emergency services like we have here in the U.S. So, you don't call 911. They're not showing up in minutes and taking you to the hospital, right? And so some countries have it in some of the larger cities, but not in all cases. And so in some cases, they may be days to weeks or months after the injury that they have the ability, they save money to pay for the trip to the hospital.
Right.
Right. And so they present late to the hospital, and some of them are going to be infected. And so you're like, how do you help them? And, without, the surgeons obviously have a lot of antibiotics that they can use. Some of them are easier to access in some countries than others. But then, that antibiotic resistance, right? That whole, there's a lot of infections that have resistance to antibiotics. And so if you keep adding antibiotics in, it's really hard. And you just keep promoting that antibiotic resistance. So we have a couple surgeons that have asked, and they're using UV lights, right? So a lot of times that's used in the U.S., but they're disinfecting whole rooms with lights, right? And so a couple of the surgeons have handheld, and they're using it as a prep before surgery. So the skin area, the local area, and we've reached out and talked to experts in the UV light field and skins and dermatologists. And so, there's a gentleman from the UK that had worked at Harvard, and the doctor there, and he's published hundreds of papers, right? And so we just call them, email them, and call them up, and half the time they answer, and then we get to talk to them, right? And so, you also don't become very bashful at sign, right? And then you explain what you're doing, and usually a lot of times, we see people are like, "Oh yeah, absolutely, we want to help." And,
so how could they not?
Yeah. So the infection control and infection prevention is one. We have another company called United Guardian. They make a product called chlorpactin. It's been around for years, since the 50s. It's actually it's considered an over-the-counter antiseptic.
Okay.
It is very similar. It's like a very strong Dakin solution, which is essentially chlorine based, but it's a more pH neutral. A lot of it's used a lot for installation on like bladder infections and things like that, urinary tract infections. But a lot of orthopedic surgeons use it as a rinse out before doing, say, a total hip or total knee, and it's like that last chance to kill any bacteria. Yeah, and so that we have a surgeon in Uganda that's doing a clinical trial over there and comparing it against the standards that they use, which is like an iodine-based product, like a betadine. Or they use acetic acid a lot of times, or just saline rinse, right? So he's doing a clinical study with that. We have a nice relationship with United Guardians where they will either donate or at cost, depending on how much we're buying. Another company called Biocomposites out of the UK. They make a calcium sulfate product called Stimulant. And so there's some U.S. surgeons and a technique that they will use where they'll mix antibiotics into that calcium sulfate. And so if you have a large bone defect or infected bone, you can make antibiotic beads out of it and place it in that surgical site, or they will actually fill the canal partway with it and press the nail into that. And then it provides additional support. And then that calcium sulfate will reabsorb over time. And then with the antibiotics there, it's really localized. And so you're not treating the whole body with it. You're treating that local infection site. So there's a FSC there in that approach. We have a couple surgeons that are starting to use that, and Biocomposites have donated some of their stimulant product to us with that. And so that's kind of another fun part that we're doing.
Wow.
Because it's an extension of some of the issues that we see in the field with some of the surgeons. And and like I said, when you have an open fracture that has presented late and they haven't had medical treatment, it's going to be infected. Right.
Well, and just to explain, like an open fracture is essentially when the bone's sticking out of your your arm or your leg.
Right.
Wow.
So that's kind of what's in the works right now, and we have lots of other little devices that we're working on. A lot of times, the one thing I didn't really talk about is one of the challenges that we face at Sign is we manufacture in house. But we also have sometimes where we need to go out of house and use contract manufacturers. So it's finding, sometimes our production volumes are low, And so you're trying to like have a design that's low cost.
Right.
But a lot of times low cost designs come with volume because you can do manufacturing processes that are less labor intensive. Like if you're stamping products or injection molding, the cost usually comes down, but you need to do a lot of volume with that. So anyway, that's one of the challenges, is trying to get to a design that's the right cost structure so that, we can treat a lot of patients with them. Right. And that's kind of been my career, right? Small volume, cost pressure, lots of cost pressure on it.
Cost pressure. Yes.
Right. I mean, that's my corporate lingo. Yeah, you got a lot of cost pressure, right? And so, which is really what it is. And so as a nonprofit, we're trying to treat more patients, right?
Oh my gosh. This is so cool. This is so cool. I didn't even realize the amount of work that you guys are doing. Thank you so much for what you do and your time, Terry. Yeah, no, absolutely. It's like I said, it's super fun to tell people about Sign, because in the orthopedic world, a lot of the Dr. Zirkle's peers who, quite frankly, are retiring and not showing up to the Orthopedic Association meetings much anymore. Right. Sign's well known. Right. But with the new generation of surgeons, particularly, I think that we're less known. And so that's going to be, that's part of the opportunity and the challenge is to get some education there. I think overseas in a lot of countries, we're very well known. I had an African surgeon that said, orthopedic trauma in Africa would not exist without Sign. That surgery, right? That's huge. That's a huge statement. Because Dr. Zirkle provided all that training, provided equipment and training. Residency programs are set up in these hospitals. And they cycle through, like in Tanzania and Kenya and Ethiopia, they cycle, some of the larger university hospitals, they cycle a lot of residents through. And those residents go off to rural hospitals. And eventually they will, there's a certain percentage of them that become Sign surgeons, right? And they will. Dedicated Sign surgeons. Mm-hmm. Wow. Right. That's beautiful. Yeah. I mean, we could do episodes on certain surgeons, right? There's there's a couple of Italian surgeons that would be super fun for you to talk to. Yeah. And the innovations that they're doing. One in particular, he's developing a phone app to do follow-up with. That's great. Oh my gosh. Okay. Yeah. Anyway, we probably got to stop. I got to go to another meeting. Out of time, but thank you so much for your time. Absolutely. Thank you for listening to this episode. If you'd like to learn more about today's topic and guest, head over to the show notes linked in the description of this episode. There, you can get access to resources, links, and ways you can get involved in the pursuit for global health. And if you loved this episode, don't forget to write me a review on Apple Podcasts and rate the podcast on Spotify. It helps me get in front of more people just like you and continues to elevate the causes we are so passionate about. I'll see you in the next one.